Primal problem. Utility maximization. Maximize u equals x, x of utility function. Subject to 2x plus 3x is less than or equal to 60 budget constraint, where u is utility. X and x are quantities of two goods. The price of x is 2. The price of x is 3. The budget is 60. Step 1. Understanding the primal problem. Imagine a consumer with a fixed budget, 60 units of money, who wants to buy two goods, x and x. The prices of these goods are 2 and 3, respectively. The consumer's goal is to maximize their utility, satisfaction, represented by the function u equals xx. The budget constraint, 2x plus 3x is less than or equal to 60, means the consumer cannot spend more than their budget. Step 2. Formulating the Lagrangian for the primal problem. To solve this constraint optimization problem, we use the Lagrangian method. The Lagrangian L is formed by combining the objective function and the constraint. L of x lambda equals xx plus lambda 60 to 2x 3x. Here, lambda is the Lagrange multiplier. It represents the shadow price of the budget constraint, which we'll interpret later. Step 3. Finding the first order conditions, FOCs. To find the optimal values of x, and lambda, we take the partial derivatives of the Lagrangian with respect to each variable and set them equal to 0. Partial differential, L slash partial differential, x equals x2 lambda equals 0. Equation 1. Partial differential, L slash partial differential, x equals x3 lambda equals 0. Equation 2. Partial differential, L slash partial differential, lambda equals 60 to 2 x3 x equals 0. Equation 3. Step 4. Solving the FOCs. From equation 1 we get x equals 2 lambda. From equation 2 we get x equals 3 lambda. Substitute these values into equation 3.
60 έως 2, 3 λεπτά, 3, 2 λεπτά, ίσον 0. 66 λεπτά έως 6 λεπτά ίσον 0. 12 λεπτά ίσον 60. Λάμδα ίσον 5.
Now substitute lambda equals 5 back into the equations for x and x. X equals 3 5 equals 15. X equals 2 5 equals 10. Step 5. Interpreting the primal solution. The consumer should buy 15 units of x and 10 units of x to maximize their utility. The maximum utility is u equals 15 times 10 equals 150. The Lagrange multiplier lambda equals 5 means that an additional unit of budget would increase the consumer's utility by 5 units. This is the marginal utility of income. Step 6. Formulating the dual problem, expenditure minimization. The dual problem asks, what is the minimum expenditure needed to achieve a certain level of utility? Let us assume the certain level of utility is 150. Minimize, E equals 2x plus 3x of expenditure. Subject to expenditure. X is greater than or equal to 150 utility constraint. Step 7. Formulating the Lagrangian for the dual problem. L of x, x mu equals 2x plus 3x plus mu, 150 minus xx. Step 8. Finding the first order conditions, FOCs, for the dual problem. L trên x bằng 20x bằng 0, L trên x bằng 30x bằng 0. Partial differential, L slash partial differential, mu equals 150 minus x, x equals 0. Step 9. Solving the FOCs for the dual problem. From the first equation, mu x equals 2, so x equals 2 by mu. From the second equation, mu x equals 3, so x equals 3 by mu. Substitute into the third equation, 3 slash mu, 2 slash mu equals 150, so 6 slash mu squared equals 150. Mu squared equals 6, 150ths equals 125th, so mu equals 1/5. Therefore, x equals 3, 1/5 equals 15, and x equals 2 by mu 1/5 equals 10. The minimal expenditure is E equals 215 plus 310 equals 60. Step 10. Interpreting the dual solution. The minimum expenditure needed to achieve a utility of 150 is 60. The values of x and x are the same as in the primal problem, 15 and 10. The dual variable mu equals 1/5. This is the inverse of the primal Lagrange multiplier. This is because the dual problem is minimizing expenditure, while the primal problem is maximizing utility. Step 11. Verifying strong duality. The optimal value of the primal objective function, utility, is 150. The optimal value of the dual objective function, expenditure, is 60. The primal budget constraint was 60, and the dual utility constraint was set to the optimal utility of the primal problem. The dual variable is the inverse of the primal variable. Intuitive explanation. The primal problem shows how to maximize satisfaction given a budget. The dual problem shows how to minimize the cost of achieving a certain level of satisfaction. Duality shows that these two problems are two sides of the same coin. The optimal quantities of goods are the same in both cases. The Lagrange multiplier in the primal problem shows how much utility will increase per unit of budget. The Lagrange multiplier in the dual problem shows how much the expenditure will increase per unit of utility.